So let's look at how do we actually calculate the mean of a data set when we don't actually have the individual data points. Instead, we've just been given the group data. So what I mean by that is the example I've got in front of me is we've recorded 172 male adult lines. However, rather than knowing the individual weight of each line here, what it's done is it's grouped this data together. So between 150 and 160, so equal to or greater than 150, but less than 160, we have two lines that fit between that category. Okay, we've got 5 lines that fit that are either equal to 160 or greater than 160 kilograms, but are less than 170. All right, we've got 17 that are between 170 and 180 essentially, 38 that are between 180 and 190, and so on and so forth. What we don't know about any of these individual lines, so let's just take these 2 individual lines here that were equal to or greater than 150 kilograms, but less than 160 kilograms. We have no idea what the actual weights of these 2 lines were. They could have both been 150 kilograms. They could have both been 159 kilograms. Something that's important to note here, if you're getting a little bit confused about these signs here, they can't be 160 kilograms because once it falls into 160, this cannot equal 160. It's got to be less than 160. All right, so 160 would fit into here. All right, so I guess the thing about this is we know that to calculate mean from previous videos, we add up all the individual data sets and then we divide by however many that there were. It's not going to work so well for us here because we don't know what the individual data sets were. So what that means for us is we can't provide a 100% accurate calculation for mean. So instead what we do is we estimate the mean of the group data. So how do we do that? Well, essentially what we say is with these 2 lines, we know that that's between 150 and 160. We don't know where they are in that data. They both could be 159. They both could be 150, like for all we know. So what we do say is we go, okay, well, let's assume that they're right in the middle of that. Let's assume that they're both 155. And we call this an interval midpoint. All right, so what we do here is we create this table here and we put an interval midpoint here of 155. And we apply that with the next one as well. We say these 5 lines, I have no idea what they are. They're somewhere between 160 and 170. So I'm going to assume that all 5 of them were 165. And then we continue with this interval midpoint with each one of these. So it'll be 175, 185, 195, 205 and 215. So then what we do here is we do what's known as a product of them, okay? So if we've assumed that both of these lines were 155 each, when we add them together, add those 2 individual data points together, we're going to be going, well, that's 2 lots of 155, all right, which is going to be 310. So the total weight of those 2 lines added together is 310 kilograms as an estimate. Once again, it might be more or less than that, but the best that we can do with the information we've got is to assume that it's in the middle, okay? And then we do that with each one of these. So we essentially say, well, we've got 5 lines that we've assumed to be 165 kilograms each. So essentially we just go 5 by 165, and that'll give us 825 kilograms as the product. Okay, so that's just 5 times 165. And we go ahead now and do that with each one of these. So it'll be 17 by 175. Okay, so now that we've done that, what we've got here is, I guess, the total of each category that we've got. All right, so each of these subclasses here of what the total weights would be. Okay, so now what we've got to do to get our mean is we've got to add them all together. Okay, so you got to remember, we've got to add all the individual data points together and then divide by however many there were. Okay, we've estimated what each individual data point would be. We've then got the total of each of those individual data points. Now we've got to add them all together. So we find that the sum of these data points is equal to 33,280. So now that we've got that, we know that the mean is going to be the sum of the data points divided by however many data points there were. Calculate the sum to be 33,280. And we know from the top here that there were 172 data points. If you didn't know how many data points there were from the question, well, the frequency tells you how many data points there were. So it was 2 lines here, 5 lines there, so that's 7 lines between them two, then you add another 17. So essentially you just add up all this row together as well, column together, as well, and you would find what you'd need to divide by. So in this case, we're dividing by 172. Which will give us a mean that is approximately equal to 193.49 kilograms. So I guess the step-by-step here, if we don't have the individual data points because we've been given a frequency table such as this, we can't provide a 100% accurate calculation for the mean. What we can do though is we can provide an estimate of the mean by using interval midpoints. That's what this process is actually called. So we're going to assume that these data points here are in the middle of the interval here. Okay, so both of them were 155, both of them are, all 5 of these are 165, and you go through that. Once you've got that, then you go, well, how much total would have I had if I had 2 lines of 155? And that gives us our product. So essentially what you're doing now is you're multiplying the frequency with the interval midpoint as your next step. Once you've got that, this now allows you to get a sum, which is what we need for our median. So we add this column here together to give us our sum that we then use in our formula here for mean, which is going to be the sum divided by however many total data points there were. Now, if the question doesn't give you how many data points there were, you would need to add up the frequency, and that is how many data points that there were that you'll need to divide by. Okay, and that is how you calculate the mean when we've got group data. And remember that this isn't going to be 100% accurate, but it's as accurate as we can get it without knowing the individual raw data. So we call this an estimation of the mean when we've got group data.